In 1777, a French nobleman asked a strange question. If you drop a needle onto a floor of parallel lines, what's the chance it lands across one? The answer turned out to hide one of the most famous numbers in mathematics, pi. Let's set it up carefully. We have a floor with parallel lines, all spaced the same distance apart. And we have a needle, whose length is exactly equal to that spacing. This matching makes the math come out clean. Now we drop the needle at random. Two things vary each time: where its center lands, and the angle it's tilted at. Some needles land clearly between two lines. Others come down across a line. That crossing is all we care about. Think about a single needle at a fixed angle. Whether it crosses depends on how far its center is from the nearest line. When the needle lies flat, parallel to the lines, it almost never crosses. When it stands perpendicular, it crosses far more often. So the chance of crossing isn't a single number. It depends on the angle, and we have to average over every possible angle. When you carry out that average across all orientations, a circle sneaks in. The reach of the needle toward the line traces a sine curve, and integrating it brings out the number pi. The result is elegant. The probability that a needle crosses a line is exactly 2 over pi. Now flip it around. If we don't know pi, but we can measure that probability by dropping needles, we can solve for pi instead. And probability is just crossings divided by total drops. So pi is roughly 2 times the number dropped, divided by the number that crossed. Let's actually run it. We start dropping needles, and keep 2 running counts. With just a handful of needles, the estimate is wild. It bounces around, nowhere near the answer. But as the needles pile into the hundreds, then thousands, the noise averages out, and the estimate settles. 3.1. 3.14. The chaos of random tosses is quietly converging on a precise constant. That's the wonder of it. Pi usually shows up in circles and waves, but here it falls out of pure randomness, with not a single circle in sight.